Probably just get started a little bit early because you're all here and waiting. And I think we've run out of pizza. Sorry about that. I was more concerned about running out of beer, so I don't think we'll do that. Hopefully we haven't done that. But there's more people here than we thought, a lot more actually. So now I'm kind of glad we put the chairs out this way. I wanted to introduce Brittany Ingram. Brittany's from CodeFresh, and they were so kind to sponsor our meetup tonight. And they're pretty relevant to OpenStack, and particularly also to containers, so super relevant for our content tonight. Brittany has some specials she's going to tell you about. I know you guys like free stuff. And we'll email you all afterwards too, so you don't have to memorize or write down everything, but I just wanted to give you guys a chance to get to know Brittany because she's going to be hosting a lot more meetups in the future. Some of them at CodeFresh in Mountain View, and maybe some even here, or we've done them together in San Francisco as well. So get to know her, and if you have a good meetup subject you want to have hosted, then talk to Brittany about it as well. But anyway, Brittany, tell us about CodeFresh.
Yeah, so thanks, Lisa. We're definitely excited to sponsor the meetup tonight. Glad we had a pretty good turnout. Sorry we ran out of pizza. Didn't know it would be this many people. But yeah, CodeFresh. So if you're currently working with Docker, you should definitely check us out. We have a free forever account for open source, and really it's a continuous integration and delivery platform that's built for containers from the ground up. So not I feel like other CIs kind of patch that over, and we're specifically designed with containers in mind. So we allow you to manage the complete life cycle of your Docker-based and container-based applications. So yeah, I mean, essentially you can go in, create a free account. We're also doing a giveaway towards the end of the month for users that sign up. We're going to be giving away a couple prizes like T-shirts, I think like some phone as well, and then also just for one person that signs up, like a gift card to have 50% off of any plan of your choice for an entire year. So that can be pretty good value upward of $1,000. So yeah, and you can kind of go in and start building, testing, and deploying Docker containers, and essentially just automate your entire workflow in one easy-to-use platform. So yeah, if you have other questions, I'm here. You can definitely grab me at the end, and I'm happy to answer them for you. Oh, and also we're having another meetup tomorrow at the CodeFresh office in Mountain View. If you're interested in learning about Docker and optimizing your CI/CD workflow, we're going to have a special guest from IronSource who runs the Data Solutions division, and he's going to be talking about optimizing CI/CD for big data solutions. So that's tomorrow in Mountain View at 6. Thanks.
All right, thank you so much. Give Brittany a big hand. Thank you very much. Okay, I am so excited to see you all here, and I mean all of you. I know a lot of you, and I know a lot of you got on airplanes to come here, which is really amazing. And some of you, one in particular, got on an airplane to come here just for this. And if you couldn't figure out why I was wearing my Austin t-shirt from the OpenStack Summit in Austin, it's because we have Austin in the house. Rob Hirschfield came all the way from Austin just to speak to you guys about this. So I know that's a huge reason about why a lot of you guys are here. John Starmer has also been so kind to be at a lot of our meetups and to help out. He and his brother Robert from Cumulus Technologies are amazing. They're certified OpenStack administrators. They have the COA titles and paperwork to go with it, and they help a lot of customers get certified. It's not an easy certification to do, so it's really awesome that they do that. And he's going to be speaking with us as well tonight. And I also want to thank Ron for recording everything. Yay! Yeah, so we will post links up afterwards. Every time I host one of these, every time I get a request for hangouts, live hangouts. We usually do a live hangout. I'm not sure what it was all, like I said, all we could do to get this thing going right now. As I mentioned earlier, to those of you that were here, the room was set for a career fair, and I need to reset it for that career fair tomorrow. So all of these little signs that are hanging on the tables in front, please do not remove them or get pizza grease on them. I was specifically told that. In fact, we took the signs from the top of the table to the front of the table so that we wouldn't get pizza grease on them. And I took pictures of the room, and we will put everything back. But just don't remove those signs. And no, we're not telling you guys that Cigna people have to sit at this table and Teladoc people have to sit at this table. It's a career fair that's happening here tomorrow. So ignore the signs. They don't exist for you guys. And if anyone is really feeling very generous, you can help us move the tables and chairs back at the end. Okay, so welcome to Hewlett Packard. Is this anyone's first time here?
Yep.
Oh, really?
Wow.
Oh, wow, okay. I didn't expect that hand to go up. Wow, okay, well, welcome.
This was Harry Potter.
We ran the Meetup here for 3 years, every other week. But yeah, so I love running the Meetups here because NASA is right there where OpenStack started. You can literally watch the sunset over where OpenStack started, which is really, really, really cool. So you are in the middle of it all, for those of you that didn't know that. And HP has been a big supporter of OpenStack for a really long time. But I know a lot of you guys have been helping in the last year to host meetups, and if you want to continue doing that, then please let me know, let Brittany know, let Sean know, let Rick know, our other co-host that isn't here today. And we are all about moving the meetup around and bringing it to locations closer to you. So speaking of moving the meetup around, the next meetup is going to be in San Francisco. And it's on, the next meetup is tomorrow night at Brittany's place in Mountain View, but the next OpenStack user group meetup is in San Francisco. This is gonna be a really fun one. We're trying to do more meetups in San Francisco, and I know it's really hard for people to travel up and down, but we used to do a lot of them up there, and we get a little bit of a different crowd. But if you can travel up there, it's worth it. It's always a different vibe, and it's a really fun meetup in the city. And the one on November 10th, I just put it on the calendar yesterday, we're going to be talking about Disk Image Builder and Zool. So Zero to DevOps with Zool. It's hosted by IBM, and they have they've done awesome work in this area, and they have some great speakers. So you guys know the names: Greg Haynes, Clint Bynum, Spencer Crum, Chris Ado. They've been at a lot of other companies, not just IBM. So Spencer from Puppet, Clint was with us for a while, and a big force behind O. Don't hold that against him. And is doing great work at IBM now. They are going to be speaking, so the gist is, where do Glance images really come from? Disk Builder is, it automatically builds and customizes OpenStack operating images. Does anybody know what Disk Image Builder is? Has anyone heard of it?
Builds VM images.
So you know about it? So could raise your hand if you've heard of Disk Image Builder. Okay, a few. I had not, so Spencer was giving me a crash course. So I'm going to go and learn all about it. But anyway, basically they call it pirate training for OpenStack. It's a little thing they do. They're also going to talk about Ansible and config management and best practices, as well as some Git tricks that you can use no matter where you fit in the OpenStack ecosystem. So that's the next meetup. It's in San Francisco. It's going to be South Market. It'll be easy to park. It's galvanized. I mean, there's parking lots around there and some street parking. So it'll be a nice location. And they haven't hosted a meetup there for a while, so they're going really big. Spending lots of money on you guys. I will tell them not to run out of food. It won't be pizza. And it may even be ice cream. Maybe. I put the request in for you. Okay, so we had Seattle Days. Did anyone go? You were there? You were there.
Where's Seattle?
Seattle. You were there. So we were up there speaking like a week and a half ago. The presentations are all online now. So if you go to OpenStack Days Seattle Days just Google OpenStack Days Seattle, and you will see all the presentations. Lots of your Bay Area user group representation. The Starmers were up there. Sean was up there speaking. He did one of the keynotes. I was up there speaking. I did one of the keynotes. Sworn was up there speaking. Yay! So it was actually a lot of really good content, and everything is up there online. We did some deep dives, and including on this topic that we're talking about today, we did a workshop showing Kubernetes on OpenStack. Actually, we're doing it the reverse way today. So, so if you want to see the other side of that story, then you can go and click on that workshop that happened in the afternoon. And Robert Starmer and Michael Schultz did a really, really good job and showed a demo. So there's lots of good content there if you guys want to catch up with that. The OpenStack Summit is happening next week. Anyone going?
my God, that's incredible.
Whoa. 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 This is why we bring this great content to you. Because that presentation is going to happen at the OpenStack Summit. It's going to be very popular, but you are seeing it first. So, and Sean is also speaking, and I'm also speaking, and you guys hear us speak all the time. But you don't get to hear Rob Hirschfield speak all the time. I know, isn't that crazy? Things are changing.
I'll have a drink for every one of you.
Okay, all right. So I know you all came in here because of our very, very, very special guest, Rob Hirschfield. If you think about Crowbar, you think about Rob Hirschfield. And he has since gone on to basically start a company and CEO of Racken. I'm sure he'll have his slides up here with his Twitter feed. So tweet us out. As always, take pictures and post them on the meetup.com site. It's always just my pictures, so I really would like other angles of the room, and so you guys make sure you take your pictures and post them up on our Meetup site. It's your user group, so take care of it, have fun with it, and
Sarmer's first, though.
oh, is he?
I think so.
You're first? I guess I should
He's
have.
using my laptop.
This is what happens when you miss meetings and you don't review agendas.
But I love my intro, so.
Did we have a meeting about this? Do you want the handheld? Do you guys want to take questions as you go, or do you want to do after?
That's an excellent question.
So the reason I ask is because we're recording, we want to make sure the questions get on the microphone. So if you have a question, raise your hand, and someone will run around to you and bring you this. Please wait until you get this before you start talking, or we're going to have to ask you to repeat everything. And that's just a pain for everything. So if you have questions, raise your hand. I'm sure these guys won't mind, and yell out or whatever, but don't yell out questions. Wait for the microphone. Okay. Yeah, that one's louder than this one. Okay, thank you. Ladies and gentlemen, John Starmer.
Stay behind you just to make sure it's...
Excellent. All right, we got technical support. Suppose I couldn't ask for much better technical support. Oh, awesome. So
I'll just fake it.
All right. So my name's John Starmer. I'm going to be giving a little bit of a prequel to what Rob was talking about, specifically about. So Rob was going to dive into the relationship between Kubernetes and OpenStack. And over the past 4 or 5 meetups, we've really been kind of dissecting this and taking it apart. So if you wanted to kind of get, we've looked at it a number of different ways. We had a really good meetup over at VMware, where Robert Starmer, the CTO of Cumulus Technologies, kind of took the pieces apart and looked at kind of all the ways that people are trying to make containers work with OpenStack. So what I'm going to try and do here is just, if you haven't been to one of those meetups, kind of give you a high-level overview of perhaps where we came from in our relationship, OpenStack's relationship with containers, and maybe where we're going to go forward, and then Ron will take over with one of those options. Like Lisa mentioned, there was the really nice demo that Robert Michael Schultz did at the Seattle OpenStack Days that really looks at the flip-flop version of what Rob's going to be talking about. If you're interested in Project Cola, our website has a demo, a single node demo of how Cola works, which is also a pretty interesting way of having that interaction. Okay, so here we are. My background is probably a little bit different than most folks in the room. My background is actually primarily biology. I worked in genetics, and because of that, you may be aware of the fact that genetics has basically exploded over the past 10 years. When I first started working with genetics, and I studied sea cucumbers, as that handsome little fellow right up there, and tried to create something like this with maybe 10,000 data points. And you're basically trying to compare those data points in n number of ways to figure out what the relationship is. The first time we had a lab mate do something like that, he ran a data set about that size on a G4 Macintosh, and he had to run it for about a month. Luckily, nobody tripped over a power cord. We didn't have a surge, power surge or anything like that, but it took a heck of a long time. I was at the University of Florida at one point, probably about 2008. We got a high-performance computing data center, and we got the cloud. Yay. Now, all of a sudden, we can do threaded processes, and what took a month as a single long process, today on a laptop, I can do it in about 10 minutes. So processing, just the capability itself was awesome. But now you're looking at being able to, rather than deal with 10,000 data points, you're dealing with millions and approaching billions of data points. And it's really not a big deal because of cloud-based technologies. Through a story which I'm not going to dive into, I'll tell you over beers afterwards if you really care, I ended up coming to the Bay Area and started teaching OpenStack. I was doing these kind of standard 3-4 day boot camps, transitioned into becoming a director of education at my current company. And now we're basically doing training 50% OpenStack, but then there's this container thing that kind of showed up a couple of years ago, right? And there it is. So the way initially when these containers, these little upstarts showed up, it was like, well, there's some like VM lights, and OpenStack's really good at dealing with VMs. We deal with bare metal. Well, this is how we should deal with containers, right? It's just another compute function that OpenStack should be able to deal with. People that were coming at it from the other way, and really the people that were driving containers were the folks from the application development side. The demand for containers, it wasn't so much, if you're looking at OpenStack like this, you're coming probably from the operations side, right? How do we provide these sorts of services, these sorts of resources to our users? And if you're looking at it from a application developer side, you don't care what the underlying infrastructure is. You don't care how you're getting that service. You just want the service. You want that thing on top here, app one, the little purple app, you want your app to run, right? And it might be that you need bare metal. It might be that you're tied to VMs. It might be that you don't have any interest in either of those and you want containers. Now, depending on what you want, and it could be a combination. The reality is we live in a hybrid world, right? Nobody really is, unless you're in a, there's some folks up north in the Bay that are very much focused on cloud native apps and containers and microservices and all that. And maybe there, a straight up container service is appropriate. But a lot of us are dealing with, have heavily invested in applications that run on VMs. We have legacy applications that perhaps need bare metal. And businesses are hybrid. There are a bunch of different use cases. So as a good operations person, you're trying to figure out how do we provide all these services most efficiently with the least headache. Now, what if we think, so we're coming from the view that OpenStack runs and deals with all of this stuff. But what if we change our viewpoint a little bit and think about OpenStack as the application that we're running? Now, I really like this microservices definition. Microservices are contentious, and many of the things perhaps we could wiggle about fine points. But really, if you look at OpenStack, it is small, we can argue that, autonomous services that are communicating by APIs. I think maybe that's the essence of that discussion. And that's really what OpenStack is doing, right? Each of our little projects, Glance, Nova, Neutron, what have you, is doing its own thing. And if you think about what happened when Nebula turned into OpenStack, turned into Nova, what did we do? We had this monolithic thing, and Swift is kind of over here doing its own thing. But we started breaking pieces apart. That's why we have Cinder. That's why we have Glance. We started basically taking this monolith and turning it into a distributed application. We can argue whether it's specifically a microservice or not. But I think it does work pretty reasonably as a microservice-like application. So if we now say, well, OpenStack is the application that we're trying to run, and we recognize that OpenStack is providing us a function, we need a reliable interface. If we're talking about high availability, something more than a single node, let's play with it sort of cluster, we need to have things that can maybe ping multiple Neutron instances, that can maybe ping multiple Rabbit instances to get our work done. We need to be able to restart, start, stop processes And we have to manage change, right? Each of our services, ideally, are going to be scoped, right? If we have to update Glance, if we have to update Neutron, we don't want to have that cause a ripple effect through our entire system, ideally. So why do applications developers like containers so much? Other than the fact that they're fast and that you can run a realistic sort of system on your laptop, as opposed to the challenge of doing that with OpenStack. You have resource bundling. It very cleanly limits scope. You have your application, you have your binaries and libraries, all plugged together, and when you deploy that container, you've deployed your application. You don't have to worry about some dependency that's floating over on another VM or server being out of sync with what you just deployed. You know what you're deploying, your app, as long as you've built it correctly, should work if you deploy that container. We have an embedded process management. We know if our app is working, if the container is up. If the container is down, it is not running. And we have a scoped unit of change, okay? If I saw a really nice demo of an OpenShift process where they basically said, look, here, we can have multiple containers, we've got a load balancer, we've got 6 versions of our web server. Now we're gonna update to version 2. And we're gonna take out 3 of those, and we're gonna keep 3 running. We can already see whether version 1 is still up, and our website is still up, and we can see what the effect of version 2 has. Everything's cool with version 2, we're gonna just take out the rest of version 1, and update the rest of those 6 now to be all version 2. And we've just updated very cleanly our entire process. So then, when we talk about containers, the containers are a thing, right? We have one application. But in reality, if we're running a big web service, for example, we probably want multiple instances running of that web service. So now we need to start managing these multiple containers, these multiple applications. There's a bunch of different services. Docker is a container format, but it is also a container management system. There used to be a separate Docker swarm, which has now become integrated, so now we don't really, Docker swarm is part of Docker, so we just talk about Docker. DCOS, a Mesos Marathon-based container management system, and then we have Kubernetes. These are really the 3 kind of big ones that we're talking about these days. So if we containerize OpenStack, how are we going to manage these containers? And these would be the 3 obvious choices. Again, we need that load balancer. All of these either have the ability to load balance or integrate with a physical or software-based load balancer. We can do this start, stop, restart process. What is more important now from a container management perspective, though, is scheduling. Very OpenStack-like, right? When Nova is figuring out where to place a VM, we have a scheduler. That's Nova's job. These container orchestration engines are doing the same thing for containers. DCOS has a really nice one. The Mesos scheduler has some nice features that I personally like, but all of them are doing a fairly reasonable job of figuring out where the resources, where can I put the next container, being aware of the fact that a container is gone and I need to put another one up. Change management, this example I told you just a second ago dealing with OpenShift, this is the sort of thing that you can do. And you can do it manually. You can say, delete these 3 instances and bring up version 2 manually if it's a small enough system, but in cloud systems, especially at scale, we want to automate those, so that's certainly possible. When we talk about containers, the 2 bugbears are always security and persistent storage. And the reality is, in many cases, probably VMs still don't go away yet because that's a nice way to deal with persistent storage. But all of these have some way of dealing with that. In some cases, they simply take containers which are typically fairly ephemeral or very ephemeral sorts of creatures and turn them into quasi/lightweight VMs that stick around longer. So they're sort of like special containers. So finally, we come to Kubernetes. All right, so we talked about there's 3 kind of leading ones. Kubernetes in an OpenStack view is more interesting to us now. We have a big announcement that certain major players in the OpenStack community are really putting their weight behind figuring out how can we get OpenStack and Kubernetes to function together effectively. Again, Kubernetes has load balancing integration. This isn't native. I was actually just corrected on this. It seems like I was under the impression that Kubernetes natively has a load balancer. It actually is able to connect to load balancers and deal with those appropriately. It has very nice segregation and process management, and it actually has this idea of pods is very interesting and differentiates it from other container management systems in that you can actually lump processes together. So if you had if for some reason you wanted to have replication, replicas where you had Nova and Glance, always replicas of Nova and Glance, you can have Nova and Glance bundled together in one of these pods. And Kubernetes is going to make sure that if you have 3 replicas of that sort of a bundle, it's always going to stick around. And this is something that really is not out of the box in other orchestration engines. There's a replication controller that deals with change management very effectively, and we have the deployment ability, and that's really one of the other powers of container management engines in general, is that if you say, I want 6 Neutron servers up and running in containers, that's going to be Kubernetes' job. If it realizes one has disappeared, it's going to make sure one pops up. And because we're looking at one of the other reasons that developers really like containers is that compared to a VM, which takes a few seconds to spin up, containers are literally on the range of milliseconds. So these recognizing something is missing and spinning something up is a very, very low overhead sort of process. Okay? And this is really just a very high overview of what a Kubernetes construct would look like. All of the orange boxes would be physical servers. You have one that's a master, and then you have these minions and containers. If we were talking about running OpenStack on Kubernetes, this is where OpenStack would be sitting, in those containers, right? And you would have pods in there, and you potentially have replicas. You could have multiple instances of Keystone, you could have multiple instances of Glance, and have Kubernetes always be sure that they have that same number of instances. The nice thing about this is that once you have this system, if your application developers want to run containers, you already have a container-native system. You can have minions that are running applications, but then you can have OpenStack also there to deal with things like bare metal and VM in the way that we're familiar with, if you so need those. Okay? Again, just sort of a high-level overview of how did we get to this discussion in the first place, and then I'm going to let Rob take it away and dive into the gory details of what Kubernetes is all about.
Also, I want to make sure that you guys aren't standing. If you want a seat, Sean, do you want to put some more chairs up here? Oh, okay. Okay, all right. So if anyone needs a chair, just drag a chair or drag one from here, and we'll put them all back. And you can turn off the mic while you're getting dressed, and then.
I didn't want to run the risk that we lose
We don't want to listen to you get dressed.
Is there a clip?
There is a clip, and there's also a. Hold on. Turn that off for a second, and then. Yeah.
Did you turn it off?
I turned it off. What do you think I was doing back there? Just saying. All right. Oh, you know, one other thing, a clip?
Were you just holding it?
No, it's on him still. Oh my gosh. Okay, so one other thing I wanted to mention, if anyone is looking for a job, somebody actually posted in the user group thing today that they're hiring. So go back to the meetup.com/OpenStack, and I don't know who posted it, but I thought that was actually kind of a nice thing to do. And so if any of you guys are hiring, you can also post in the Meetup group. I have no problem with that. And you can, then you know who to network with afterwards and whatever. So if you're looking for a job, look at whoever posted that thing. You're the one who posted it? I don't know, it was nice of you. You want to tell us about the job you have while Rob's setting this up?
That's great.
We're looking for an
Hold on, wait, put it on mic.
With Hampshire, we're looking for an OpenStack engineer in Phoenix.
Does it have to be located in Phoenix?
Yes.
No remote, modern day, we all have Wi-Fi and laptops and video cameras and... All right, sorry, I logged it for you guys. I hear Phoenix is really nice this time of year. Okay. Anyway, if anyone has any jobs here, You don't want to tell anyone about. Where's Artie? He's always got jobs. All right, are we ready? You want me to turn it back on?
That's on.
Oh, bummer. Just kidding.
Just turn it off.
We go
Yeah,
way back.
if you want.
I love these guys, and we have a lot of fun together, if you haven't noticed, so. Okay, go for it, Bob.
Okay. So this is a preview. You don't get the rough draft version, if you want to think about it that way, of my Will It Blend Joint OpenStack Kubernetes environment presentation. And so, to save you a lot of time, since you probably want to all dash off and watch the huge event going on TV right now,
Baseball game?
the simple answer is not today, but in the future. And we're going to talk about whys and hows and whats. Let me give you a little bit of my background, so that'll help you understand my perspective in this and why and how I come to these opinions. My name is Rob Hirschfeld. Online, a lot of you might know me as Zehicle, like vehicle but with a Z. And I've been getting tweeted, thank you very much, about this. I was on the OpenStack board for 4 years. On the OpenStack side of the house, I really worked to champion operators, core. I ran the Dev Core project for a long time. My team at a current position, which is RackN, wrote the first OpenStack installer, which is still SUSE's installer, something called Crowbar, way back in the day. And now I am the co-chair of the Kubernetes Cluster Ops SIG, which means we try to get operators who are trying to operate Kubernetes together, because we're trying to avoid the mistakes of OpenStack, very literally, where operators weren't organized until a couple of releases in, and so we're trying to get operators to talk, right? Have a group, have an opinion, and be part of the conversation. And you'll see why that's very important to me. Professionally, I've co-founded a company called RackN, and I can show you a little bit about what RackN does. We build hybrid automation, so we take DevOps effectively and we let it run between Metal, do full lifecycle on Metal, but also on cloud and cloud infrastructure. Right? So one of the things that my team's been busy doing is actually building Kubernetes deployments that run in a decomposed way on Metal, Amazon, Google, OpenStack, things like that. And actually I have one, I can show it in the background, it's a live demo. It's not exactly the point here, but you know, part of the things that we're doing is socializing how do you operate Kubernetes and operate it well. For that perspective, I will actually go, I did a deployment already on Google. And this will make sense. I'm going to start the deployment so it's running in the background. I did one on Google, I'll do one on Amazon. So it's just going to build a 4-node cluster for me. This is the actual JSON that tells it how to deploy it, and I'll say go. And so in the background of the demo on my cell modem, I'm going to do a Kubernetes deployment on Amazon to match the one I did in Google. And we'll talk about, and if you have questions, I can show you how we decompose it, how we break into small functions and pieces and things like that. That's what RackN does. It's what we really believe very strongly in, which is all about operability, how you take projects like OpenStack or Kubernetes or Docker, or Swarm or Mesos, and turn them into something that is day 2 operational. Right? And this is really, to me, where the story is going to pick up. So I'll leave it on the view where you can actually watch it and flip back at some point. Build the Kubernetes deployment. Okay. So John did a good job talking about what is Kubernetes. Sort of gave you some background and pieces and parts. It's a container scheduler. People will throw around the word orchestration. I think scheduler, for those of you who care about the distinction, is probably a better description of what Kubernetes is doing. A lot like how Nova schedules VMs on systems. There's Kubernetes is scheduling containers on systems. And it's really an API-driven infrastructure. So there's a whole bunch of people adding things above, around, and beside Kubernetes that take advantage of the API. Kubernetes itself is really an API-driven infrastructure that handles container, restart, replacement, lifecycle, things like that. Okay, so think of, if you're thinking about OpenStack, think of it as Nova. And then everything else is really separate projects. And the point I like to make is that Kubernetes is not a silver bullet. is designed to run applications that are designed to run on Kubernetes. And I'll come back to this theme, it's a really important one. But if you are going to use any containerized infrastructure, Kubernetes, as much as any of the other ones, we're talking about things called immutable infrastructure. How many people are used to that term, immutable? Okay. If you're dealing with containers, you need to learn that. It's a horrible term because it doesn't mean much to most people. What it means is that inside your container, you're not storing state, fundamentally. So that means if your container dies, you don't care. That's sort of what, there's a lot of other meanings to it, but that's the one to think about. There's something called 12-factor configuration. There's another buzzword. You can go look up 12-factor auth or configuration if you haven't seen it. How many people know about 12-factor? Okay, about the same group. 12-factor is another thing embedded in the design patterns that containerized infrastructure uses, because to make a stateless application that works in containers, you have to inject configuration into that container. You can't chef it or Ansible it because that container doesn't exist long enough for you to actually go and SSH into the container and configure it. And they're service-oriented, right? So John did a good job talking about OpenStack services. A lot of containerized things are even smaller service windows. The rebar stuff I'm showing you in the background is actually 12 separate containers where DNS is a service, very, very small service. And this is something that the cluster OpsSig put together. It's one of a series of diagrams that sort of tries to help people quickly understand Kubernetes. This is the middle, so I apologize. I did a presentation actually last night where we all went farther through this. And I'm presenting it because my assumption is that John educated you on Kubernetes and containers a little bit, but you're still going to need to know enough about Kubernetes to understand the position that I'm about to present. So, looks pretty scary. Maybe if you remember the old OpenStack drawings days, this may give you some deja vu of the good old days when we were talking about Cactus and Diablo, before things got crazy. And it's actually pretty good. The thing is, of all the stuff that's on that, a lot of it's support infrastructure. Kubernetes is really two services. There's a scheduler, there's an API service that front ends an object store database called etcd, and there's a kubelet, which actually starts and stops containers. And those two have a RESTful interface between them, and that's pretty much it. A lot of other stuff. There's some other stuff in there, but that's Kubernetes, those two services. Not that hard. So before we go in, I want to set an expectation that's really important to me. I think it should be important to OpenStack people in general, Kubernetes people. It's about operators, right? The purpose of this conversation, the purpose of whole joint OpenStack Kubernetes environment is that you are trying to operate the infrastructure more effectively. Not install it, operate it. So operators have specific needs, and they're essential to success. One of the things OpenStack has been struggling with is its operational complexity and how it has a reputation of being very hard to use. It's a really hard reputation to overcome, right? And so it's important to think about that. And sometimes you get times where vendors who want to sell you a whole really complex, hey, we can help you make this work, they'll sell the complexity. That's a whole other story. I'm going to put my rants down on the table. So the idea here is that operators want to see things that are simple and transparent and stable, right? They don't want to see a lot of gears turning, or if they're turning, they want to see them turn. They don't want black boxes that they can't open. They don't want to become a super user in their platform in order to run the platform. So like the triple O concept that Lisa was talking about so fondly, the idea that you have to learn OpenStack before you can run OpenStack is problematic for an operator who really just wants to keep their data center running. Right? They don't want to be cracking open the OpenStack manual and figure out why Nova crashed. And then scale, upgradability are both things that are done inside the project and outside the project. So if I'm going to do an OpenStack upgrade, there's things that I do for an upgrade that are external to the project. There are things that I do internal to the project, like make the APIs N+1 version compatible, that help you do upgrades. So you can't just, sort of throw a upgrade magic potion in your operational environment and have it suddenly work. The app has to be ready for it, and the environment has to be ready for it. So 2 things. And just as an opinion piece, generally I find Kubernetes to be operationally well designed. Right. So part of the idea here is, hey, Kubernetes looks really cool and spiffy, and people like Google, and they're pretty smart about it. So we're gonna go with that. And fundamentally, I think Kubernetes is a good thing. Right. Everybody with me? Good. So first, boy, we did some really serious harm, in my opinion, to OpenStack in this Kubernetes OpenStack marketing commingling. Okay? Because what I heard when I talked to people in the industry is Kubernetes is stable, OpenStack is not. We're going to run some Kubernetes on OpenStack and solve its problems. That's what the market, you guys can say, yeah, no. That's what the market heard, right? When we got up and said we're going to run OpenStack on Kubernetes, and I'll explain that more in detail, marketing, bad mojo. Right? And it also confuses OpenStack Foundations. I was on the board. Key message for OpenStack Foundation is one platform for containers, metal, and VMs. True or not, doesn't matter, that's the message. This is confusing that. So marketing is important. Right? There are people promoting it. Morantis has been a big speaker. CoreOS, those were the 2 people up on stage in Austin promoting it. But there are other people behind the scenes who really want to see this work. And then the other thing that is concerning to me in this whole conversation is it's confusing, and I'm coining this term, plain old container installers, cookies. Yeah. It's going to stick. Tim's going to retweet it, and everybody's going to be doing it.
It's a thing.
It's a thing. So if you look at, if you do a survey of OpenStack installers, that help you, what you're going to find is there's a lot of OpenStack installers that use containers as their delivery mechanism or their packaging mechanism. But they actually do it very differently. So you've got Juju doing building a VM and then stuffing things inside of it. You've got Cola that takes some prepackaged VMs and then uses Ansible to position them. You've got OpenStack Ansible, which is a little bit of both. And the reality is there's a whole bunch of people doing that. And there's a perception, if I've done things in containers, I can now do container orchestration. And that is not true. Okay? And we'll talk about that. If you're with me, I want to stop for a second and describe overlay versus underlay. So when we're talking about Kubernetes and OpenStack, you're right. At Seattle, people do Kubernetes installs on Amazon and Google. That's the overlay, right? Infrastructure, container stuff on top, overlay. We're talking about underlay. So the underlay idea is that I take my infrastructure, I put a platform on it, and then I install things on that platform. So that's the underlay piece here. This conversation is really targeted at using Kubernetes as an underlay. And that's important because when people think about running OpenStack, they don't think about running OpenStack on Amazon. They think about running OpenStack on physical infrastructure and creating a cloud. Which means that the fundamental premise with all this stuff is that you're going to run the Kubernetes infrastructure on the metal first, and then put OpenStack on top of it, and then put Kubernetes on top of it again, because OpenStack just did a really good job telling you how awesome Kubernetes was. And if you didn't get that message, then you didn't hear the marketing fluff correctly. This is my problem with the whole marketing message. And if you think about the OpenStack sandwich, I'm going to harp on my marketing step a little bit. The OpenStack sandwich, when I talk to people in the field who aren't OpenStack enthusiasts, they scratch their head about the meat in this sandwich. So my second why I'm scared about the Kubernetes, and I'll actually get to the points where it's good. Trust me, I'll get there.
We're to putting the rants on the table.
They're there. I actually deleted some rant slides completely. My DevStack rant slide.
We've been here all night.
Yeah. So here's the other thing that has me scared. I have to put these on, and then we'll talk about the real technical issues and real technical benefits. But OpenStack has had a 5-year journey of trying to fix operational problems in various different ways without actually solving operational problems. And one of the things I'm concerned about is that we're really just, if we really embrace this mechanism, what we're doing is we're not solving the operational problems like with logging hygiene and N+1 API compatibility and things like that. What we're really doing is we're saying, hey, look, there's a new bright shiny thing. We're all going to go learn Kubernetes. We'll fix the OpenStack ops stuff soon, I promise. First, we're going to play with Kubernetes. And that is actually a very valid concern because it's just plumbing, fixing ops things, right? We support RAID and BIOS configuration. It's about as boring as you can get. But if it's not right, it doesn't work. So you gotta do the plumbing work to make things happen. And then what you start throwing in here is, well, wait a second, put on your operator hat. Now I've got to deal with Kubernetes and OpenStack. Oh, okay. So I've got a new thing to learn before I can just operate OpenStack. Where's the simple? If it doesn't actually reduce my tooling infrastructure, is that really moving me down the field, right? We still have to have packaging for Kubernetes, for containers. So we still have that. We still have an OpenStack packaging fund, which people are doing. That's good. We're relying on Docker to keep things running. How many people have experience with Docker being rock solid, stable, build my infrastructure? So right, Docker, while it's an amazing revolutionary technology, is built on containers. Containers are very solid. Docker isn't necessarily that solid. So if you're building something on top of Docker, you better be prepared for the daemon to crash occasionally, right? Or you have to deal with upgrade problems every once in a while, every couple of weeks. So those are challenges. And if you're just thinking about Kubernetes in general and containers, we're still working on storage and networking in those technologies, right? Neutron's already done, we're all good, great, we got networking solved in OpenStack. My sarcasm's not playing in the room. And now we got to, we're just going to fix it in networking too, because we're in containers. It's just we've done it, fixed. So put concerns on the table, grants are out. It's going to happen anyway, right? So the reality here is that whether you think it's a wonderful idea or not, the momentum, the marketing message, the community enthusiasm is going to drive us into this conversation either way. So put on your seatbelts, the ride's off, we're already on the roller coaster ride, you can just hear the click, click, click as we go up to the top of the ride. So concerns on the table now. The question is, all right, so what are we actually talking about? What is it going to take to build this joint OpenStack Kubernetes environment? The first thing we need to do is understand the difference between containerization and Kubernetes, or what you could talk about as microservices applications or whatever. I'm using Kubernetes as a placeholder for container orchestration systems, applications that run on container orchestration. This is a little bit repetitive. But so if you're just thinking of containers as lightweight packages or as daemon sets, right? So just a way to run code for you. Like, so I spin up a container and it's running in daemon because I really don't like systemd. I actually do like systemd. Anybody else like systemd? Yeah. So you don't like systemd, you don't even understand what systemd is, go take the book. Systemd are actually pretty good. But you're like, I gotta run the code. If I put it in a container and exec it at the bottom of my Docker run file, it's gonna run for me. Docker's gonna keep it running all the time, and everything's good. That's a good use for containers, but it's not actually the same thing as running something in Kubernetes. Because Kubernetes brings in a whole bunch of assumptions about how it's going to schedule and manage and run your infrastructure, right? It's going to move things, it's going to stop things, it's going to move networking around. It's going to really take care of, it's very opinionated, it's going to take care of how you inject configuration into that container. You're going to have to adapt to that, right? You're going to have services orchestration. You're going to have to be able to say, all right, where did my Nova API controller go? Oh, wait, it moved over here. It's got to be okay. Stop in the middle of doing something. oops, I gotta pick that back up because my container just died, my system rescheduled itself. You have to deal with all of that. And one of the key things about this is you have to be able to handle services changing their IP addresses. Okay, not a big deal, right? Most people, you all use DNS names, it's certain, right? When you code, you write your apps, you use DNS, you never rely on IP addresses as your actual token. Good. But so in what's DNS? Yeah, I just coded the IPv6 addresses in hand by hand. That's my approach. It keeps me from having to create new certificates as much. Yeah, you don't follow any of my advice today. So the idea here is that in a containerized environment, we're relying on load balancers, we're relying on systems to move containers around, and the containers don't move with their IPs, they just bring up a new container with a new address and count on you being able to discover that new service has come from somewhere else. Right? It's a different model, which is different. So if I'm just using Cola to spin up containers, that container is pinned on a server. Right? There's a lot of Ansible code out there that will start a container for you on a server, map it to the NIC, and just broadcast it as if it's just a process running on that server. All the container scheduling and movement, abstraction, not a fact. If you're using most of the container, the pokies, they're not. They actually obscure all that. You don't get that for free. And the reason they do that is because that is how you get the magic unicorn of HA upgrade and things like that. So the slides are out of order from the way I'm talking about them. Oh, all right, maybe I deleted the wrong slide. So I'm going to pause for a second, ignore the text for a minute. So why do people want to do this? The goal for Kubernetes, the thing that is the promise of Kubernetes and Swarm and Mesos and Rancher, and there's 20 of them now, container orchestration systems, is that they're going to keep your application up. They're going to allow you to replace versions and do a migration, and they're going to give you HA for free. So if you use Kubernetes, it is much easier to write an HA application and roll upgrades through that application, period. But it doesn't work for the application you have on your servers today. It works for the applications that are written to use Kubernetes and conform to its operational characteristics. Okay? So for us to get to that point, what we have to be able to do is not pin containers to servers and expect IP addresses to settle. We have to figure out how to deal with our different SDN layers, right? So Kubernetes has its own software-defined networking. It doesn't make sense to tunnel neutron traffic through Calico traffic and out, which is flannel or so there's networking issues from this. So we have multiple layers SDNs. If you were going to put Kubernetes on top again, you'd actually have an SDN on top of SDN on top of SDN. It's a little bit confusing. Once again, operators not very happy when you're trying to figure out which layer of tunneling you've encrypted traffic through. Okay, and then right, and then one of the other things about the difference between a typical deployment and a Kubernetes deployment is you're going to give up control over your ownership of when that container is scheduled and managed and how it's going to be managed. So from an operational perspective, a Kubernetes application is delegating that control to Kubernetes because that is how it creates the magic upgrades and rollouts and things like that. Does that make sense? Yeah. So in order for us to do a Kubernetes deployment, an OpenStack deployment on Kubernetes, what we really need to be able to do is cope with complexity. So we have to not add infrastructure into the environment in a way that makes the system more complex. Right? If I show up with a Kubernetes deployment that looks harder than an OpenStack Ansible deployment, I've got a loss. Right? We've moved the needle in the wrong direction. And I better make sure that when I do that, my Kubernetes infrastructure is an order of magnitude more stable than my OpenStack infrastructure. Because if I'm doing and Kubernetes is not even, I think they had their 1-year anniversary, right? So it's a good infrastructure, use it, but be aware, it's new. So if I'm administrating OpenStack, and you're calling, and I'm like, hey, I'm having a problem with Keystone being stable. And you're like, yeah, well, I'm sorry, your kubelet needs to be revved because your Docker version changed, and that's what's causing you to have unstable, Keystone. That's a problem, right? So Kubernetes can run applications very stably, but you got to figure out where you're going to start doing the troubleshooting before you add Kubernetes into the environment. These are very real questions. We have to make sure we have stable, repeatable Kubernetes before we throw it underneath things. We have to figure out how we deal with tiers of servers. John was talking about load balancers. Kubernetes will route traffic, inbound traffic to the correct container, but it doesn't magically load balance. Magic load balancing is it's not even a Docker feature, Docker Swarm feature. If you have a cluster and you route all of your traffic into one node on that cluster, you have a failure point. The only way to get a HA cluster, even if the containers move around and they keep themselves up, is if you're distributing traffic into that cluster also. And Kubernetes, most people don't realize this when they play with Kubernetes, Kubernetes in Amazon and Google will integrate to the native load balancers on those platforms and distribute traffic using them. It's sort of quietly done by the automatic deployment stuff. If you're on your own premises doing it, you better find a load balancer. If you're doing OpenStack HA, you better find a load balancer. Load balancing, you just need it. There's no magic pixie dust that makes this stuff go away. We have to deal with IP mobility. So the fact that I bring up a container and the IP is allocated for me and then moves somewhere else, we have to have infrastructure within OpenStack that's robust to IPs being changed. And that's a very real concern if you've been depending on IP stability because you're used to, I put a server out here that has, this is my Nova compute node 6, and it's got this IP address, and I'm going to send traffic to it on this IP address. If that IP address starts to flap around, you're going to have a lot of trouble finding where that server is. Or you need another way to identify that server that's persistent, or you basically pin Kubernetes to a server and turn off Kubernetes. And I would argue that if you're going to start turning off Kubernetes features, don't use it. And then, all right, so mixed networking nodes I talked about. There's a utility challenge of now I've got to figure out upgrades for Kubernetes. So don't just assume that I'm going to take version 1.4 of Kubernetes and install it, and it's going to sit there forever as a rock-solid underlay, right? It's going to need upgrades and patches and all those other things, just like everything else does. And then you also have the challenge of mixing Kubernetes workloads. So this is something that I've heard people say they're not going to do with Kubernetes. One of the things that's exciting about Kubernetes, I'm listening to a whole bunch of ISVs who want to deploy Kubernetes into, Tim's figured out he can Facebook me and it shows up on the screen, I love it. I wish I knew how to turn that. All right, so the interesting thing here is that I'm hearing a lot of ISVs who are writing applications using Kubernetes as their underlay because they want the free HA upgrade capability, and they should. So they rewrite their application for Kubernetes, and then they come into your site and they say, yeah, we're going to install our application. First, we're going to install Kubernetes. Right? And they use Kubernetes as an underlay for their application. It's really cool because it's portable across multiple infrastructures. Big win, everybody's happy. They might not even tell you, the ISVs I'm talking to, they don't even tell you they're installing Kubernetes. They just take a couple nodes, they install Kubernetes infrastructure, maybe an all-in-one, and then poof, they're using Kubernetes behind the scenes and you don't even know. Which is really cool until you got about 4 of those. And then you're like, hey, wait a second, I really want to put Kubernetes, I already have Kubernetes down here, I'm going to do that and manage it and run it, and then I'm going to start dropping applications in as a common underlay. Which sounds really cool, until you start thinking like, well, wait a second, how does OpenStack mix with application foo, and has foo mix with application var? These are real operational concerns that now we're going to have to deal with. I'm looking forward to Kubernetes getting to that point. I can tell you based on my experience in the ecosystem, Kubernetes is moving there really fast. So why, you guys are probably like, all right, I'm done. We're never going to use Kubernetes. We're never going to put Kubernetes on OpenStack. I told you it's actually useful, and there are benefits to doing it. This is where my slides are a little out of order. Sorry about being the rehearsal audience. The idea here is, first, Kubernetes has a great ecosystem. Okay? There's people doing networking work, there's storage work, there's security work that's really fascinating coming into the Kubernetes and container space. There's a whole bunch, like I said, of ISVs that are coming in. There's things like OpenShift and Deis, Orbit, I can go on. There's a whole bunch of people writing application stuff using Kubernetes as an underlay, so you can come in and say, oh, I have an application, I'm going to run it through a platform, and there's people writing those things. It's really awesome. And they're cloud portable. Docker is actually really useful as a way to do packaging. That's why so many people are doing these pokey applications. I'm going to crack up every time I say that. But they're doing these, they're using containers to wrap things because frankly, it's really good. If you're not using containers to at least get separation of concerns in packaging, stop what you're doing, go learn how to do that and start. Is everybody here using Docker, at least to some extent? Okay. Phew. That's the honesty test. Everybody passed. Thank you. But if you're not using containers to package your applications, stop. Do it. It's immediately valuable. Our practice when we converted our application from monolithic applications in Docker to actual microservices and containers, and really use containers the right way, we cut our install time by a factor of 10. Okay? And our issues and dilemmas and challenges and bandwidth dropped just dramatically. It's huge, huge benefit. And that's just the surface. Upgrades do benefit. So Google really did a good job, and it's not just Google, but I like Kubernetes upgrade methodology, and other people are copying it. They really did a nice job of A/B upgrades and rolling upgrades and how you do container replacement, have a methodology for doing that. So that's really useful. There's actually a job scheduler in Kubernetes that would be fantastically useful to be able to say, oh, I just have a one-shot thing, or I need to put something on a timer, I want to go do some work. That's really useful stuff, right? Operationally, we need to do little jobs, run a batch, do something like that. There's some really cool Lambda type stuff coming. Friends at a company called Iron that's really cool. I love to promote friends. And so that is really interesting stuff. Kubernetes has some of that built into it. And you can just take advantage of those capabilities that would help maintain OpenStack. It would also help schedule OpenStack upgrades and works. There is a free fault tolerance capability. So if a server dies or a container dies, Kubernetes restarts it. That's that's a really big deal because it restarts it automatically. So it's not vMotion because it doesn't preserve state, but it keeps your infrastructure running and it redirects the traffic to where the new container moved to. Right? So tons of free functionality that we want to take advantage of that really would make OpenStack a much more robust infrastructure. So if you go to a world where Kubernetes is already running, putting OpenStack into a Kubernetes infrastructure should be easier. I should be able to write a manifest file and poof, have OpenStack installed for me. That would be really nice. I'm still not entirely sure what you would use OpenStack for in that environment, maybe to run some VMs, but we would use it. Once again, we're back to marketing problems. And this is going to sound funny, but I think it's actually a very real thing. If OpenStack as a group said, hey, we really think this Kubernetes underlay thing is a great idea, we're going to do it, it's going to constrain choices in OpenStack so that you're actually not going to have 20,000 ways to do something correctly. Maybe. Maybe that's just the way the world is. So how could we do it? I'm like 5 minutes, and then we'll get questions. So if we really want to do this, and I've seen some of the plans that are coming out of Mirantis, I've seen some of the plans, I don't think Lockie made it here. Lockie Everson, who was, did a whole bunch of Kubernetes work early and was promoting some of these concepts. Been talking to people. I'm happy to talk to more people and get their opinions on this. What you do is you do a low-hanging fruit approach. You say, look, I want to get maximum benefit I can from Kubernetes quickly. I'm going to take the web servicey things for OpenStack that I can take state away from, do those. Put those in containers, run those in Kubernetes, let them schedule Nova, controller, and Keystone, and there's plenty of web servicey things that you can just run as web services. Things that don't like being moved around and being bounced all the time, like Rabbit and databases, and potentially Glance, where there's an image store, depending on how you do with your Glance. Those things, you don't have to do them yet, right? Now, the fundamental problem here is that while this type of model gets you into Kubernetes and gets the benefits from Kubernetes, it doesn't address a whole bunch of the other issues, like is Kubernetes stable and how do I upgrade Kubernetes? And now you've actually added complexity into your environment because now I've got to run Kubernetes, still have to figure out how to run and maintain my database server, my Rabbit MQ server, and I still have to run all the nodes because I'm saying don't use Kubernetes on the nodes because it's just agents running on the nodes, it's not that hard. But now you still got to manage and orchestrate and control and do all this other stuff. So I've gotten some benefits from Kubernetes, but I've just added something into my environment that's going to take 2 or 3 years for us to do. And most importantly, you've got to have OpenStack able to handle immutable objects, or immutability, which means that you have to be able to take an OpenStack service, tear it down, bring it up someplace else, and then let it run, or run it in 2 places and have it be okay as things move around. And some of these things work, some of them not so much. Right? It's not been a design priority. It's not a fault for OpenStack. It's not a design priority for OpenStack to create immutable services. Right? Mutable services would use console or etcd to store their state configuration so that you didn't have to inject it via files. Little things like that. So in summary, OpenStack operability is not solved by the underlay alone. Right? You do not rub Kubernetes on OpenStack and gain HA capabilities. Right? People telling you that, it should be an obvious, it should be obvious that it doesn't happen for anybody's application. So it's not just an underlay thing, and we shouldn't get caught up in saying it. Also, it requires us to do architectural work to take advantage of these capabilities. That work is led in OpenStack by the technical committee and the PTLs and the projects, and they have to make the leadership decisions to prioritize that architectural work in order for this to happen. So if we want to start seeing more immutable capabilities and service registration and persistence challenge, all these things addressed, has to be a technical priority for the leaders of those projects to do it. And then I would argue it's got to be a cross-the-board thing, because if Keystone says we're all in, but Nova's not, we're not really marching to the same beat. Unfortunately, OpenStack's not really structured in a way to make those types of sweeping architectural changes all at once, so it would have to roll through from an infrastructure perspective. And we have to resolve this OpenStack Kubernetes messaging issues, right? If we go around telling people how great Kubernetes is and it's going to solve all these problems in OpenStack, the message that the market's going to hear is Kubernetes is going to solve a whole bunch of problems for you. Which, I'll tell you, I think that's a reasonable statement, but it's not the statement that you want to be promoting in OpenStack necessarily, right? Or at least, putting on my board hat for a second, it's fine message, just make sure it's the one that you want out there, right? Messaging should always be intentional, and I don't feel like it's been that intentional. But I do think that for 2 reasons, I think this is required. So I think that these design parameters are good parameters and generally healthy parameters. I think OpenStack must do this. in part because my assessment is that Kubernetes is going to be bigger. Okay? And very simply why? It runs in Amazon, it runs in Google, it runs on VMware, right? It runs on OpenStack. Operationally, companies are replatforming, ISVs are mapping their functionality to Kubernetes. They didn't do it to OpenStack. That didn't happen. And so the reality that I see in market is a lot more people are going to be working Kubernetes first and OpenStack second. Or OpenStack, that's an operational choice people make. It's not an application development choice. And so the footprint for Kubernetes is on target to be much bigger than the footprint for people who are using OpenStack. It's a reality. I'm sorry if that's troubling for people, but that's how I see the market. And that is my last slide. So I'll pause. Questions?
Oh my gosh, so many questions. Yes. I agree with you, by the way. I think that what you said about OpenStack absolutely needing to do this because of how big Kubernetes is going to be is absolutely right on time. And we got one question. Well, we'll get there. We will do all questions. But there's been a question that's been asked at the last 4 meetups, and I promised I would cue it. That was only asked at the last 2 meetups. But it was asked by the same person, not to mention names, about the differences between Docker and Kubernetes and your preference of one over the other.
Oh, that's a great question. So there's a huge, and I have a nice blog post about this. Docker's 2 things. So Docker is a runtime engine that helps schedule, helps run containers on a single system, right? And we use it all the time. It's a great utility. It's not the best utility. In some cases, we actually use systemd. But Kubernetes is a thing that schedules Docker runtime. The company Docker has a suite of products, including Docker Swarm, and Data Center, and Registry, and a whole bunch of other stuff. I have a preference for Kubernetes of those 2 for a whole host of reasons. But I think architecturally, Kubernetes is very, very clean. It's a little bit more complex than Swarm. We use Docker Compose. Actually, our application uses Compose, which we think is an awesome onboarding way to get containers up. Highly recommend Compose, but it's only going to be good for 1 or 2 servers. As soon as you cross that sort of threshold, you're going to need a container scheduling thing. And the other thing I really like about Kubernetes compared to everybody else, and the OpenStack people, y'all should really appreciate this. It's very community-minded. So most of the other tools out there are single vendor tools. And so, and Docker's an example of this. I'll say this in the nicest way, but they're a single vendor tool. If you want to do things interesting with Docker, you really end up working with Docker, the company, to make that happen. Kubernetes, you can just go do stuff. Or you can show up in SIG, you can play in community, and they're not, Google's leadership, they're not trying to monetize a platform on top of Kubernetes or a networking layer or storage underneath of it. They were like, it's this little layer that does scheduling, and then you get huge, if people try and stretch that box a little bit, you get huge pushback. No. It just does this, doesn't do that. And so it's very nice to see the community have a very tightly constrained vision. Remember, I was the guy to the Dev Corps. Have a community with a very tightly constrained vision of what it does, and then leave the rest of it to the ecosystem. And so, to me, that, especially talking to an OpenStack crowd, is something that people should be thinking of as an important component in building a platform.
Yeah, that is huge, and I'm glad to hear that we're all in agreement. You said the same thing that the last couple of people I've asked have said that, and also what I said and what Robert Stormer said on stage during the keynote in Seattle, particularly the community side of it, because a few of us were at the DockerCon in Seattle. In fact, I was working the OpenStack booth, so we got that question a lot. And when they announced SwarmKit, they really isolated the community because they kind of went off and built that a little bit on their own. I mean, they said that they used the Docker, what do they call it, the Docker captains. They reviewed it with them, but the community really had some problems with that and with their kind of saying, you don't need to Kubernetes,
So-
cases, you know.
So the backstory, if people aren't familiar with the backstory, when Docker in the last version secretly injected their Swarm product into the runtime as a feature and then announced it. And so a lot of the people who were in the Docker community didn't see that coming. They weren't party to that conversation. It was sort of done very quietly, and then, I'm using very, very polite language. It was done very quietly and then announced as a big bang at the show in a way that was perceived as very competitive with a lot of the ecosystems like the Ranchers and Kubernetes and the Mesos Marathon. Mesos is...
And the Open Container Initiative, all the kind of work they've been doing to...
Yeah, and the vendors in the community have OCI and CNCF, Cloud Native Compute Foundation, which are trying to help create open standards for this. In Docker's defense, I can argue both sides of this. Yeah, all right, there's no defense. In Docker's defense, they are trying to innovate very quickly. There's a whole bunch of uncompleted things in this space, and so they feel like they have to race ahead to deliver functionality that their customers want. The challenge is their customers want it, but their partners are not as excited to see the engine get bigger. So it'd be like somebody taking Cloud Stack and stuffing it into KVM. Would be the comparable story. And all the OpenStack people would be like, but I use KVM, I don't use Cloud Stack. Why did you put that code in there? And that's effectively the response people got from that. Yeah, there's fun archaeology on all this stuff. I love the open source politics.
Right. Yeah, open source community wasn't influenced by that. And the flip side of that is Google has been pretty amazing, actually. And I didn't even realize Sarah Novotny was following my keynote at OpenStack Days. I didn't even know she was there. And so I've been like raving about Kubernetes and how open the community's been and how great they've been to work with. And it helps that they're 5 minutes there and they feed us free lunch. So maybe I'm a little biased because you know that my stomach is the way of my heart, or something like that.
They've made, so Sarah Novotny has done a whole bunch of community work. She leads the Kubernetes community. She's really upped the game on that. They brought her in to do that. But it's not just Sarah. I mean, Sarah, she's awesome. You're awesome, Sarah, if you're watching.
I invited her tonight, she couldn't make it. She will come and speak to you. She's moved here. She lives here now. So she will come and speak to you at this meetup in the very near future, yes.
But that, the people, people do matter in these things. There's a whole bunch of SIGs. Please, if you're operating Kubernetes, come to our SIG meetups. We meet every week. We write docs. We talk about Kubernetes ops. No, Kubernetes doesn't do IRC.
What?
Kubernetes does face-to-face meetings using Hangout.
What is that?
And so yeah.
They're proprietarily using Google? What?
Actually, they prefer Zoom if you want, but some of us, I actually prefer Zoom too. But no, we have big face-to-face meetings using interactive technologies, and so the meetings that we have were recorded. And then if you show up, you can speak, and we'll do back channel chats also, but for the most part it's Slack and Zoom and Google Hangouts for the meetings. And then there's a whole bunch of SIGs that meet all on a regular basis. And then they use GitHub for their code.
Fine technology.
Crazy.
That's like the first meetup I have on GitHub, sure, and probably like 10 meetups ago.
So it's really good. I mean, I've been having a lot of fun. Obviously, I was huge in OpenStack for a long, long time. I still think there's tremendous potential, capability within the platform, but when Kubernetes is up and coming, and y'all should be paying attention.
Okay, so we do have some questions, and I am going to take them on back first, and then do you still have a question? Uh-oh, did we cover it, or that was your question? Okay, I could just read mine and I'll just ask all your questions. Okay, so we'll go here. And some of you are leaving early, don't even think about leaving food or beer on your table. There are vehicles here to throw things away in and recycle. Here? Okay, sorry, I can, okay.
So it seems like there's maybe 2 pretty deep topics here. One is that maybe that OpenStack is kind of hard to install and run successful.
I would never imply that. Never.
And
Go ahead, yes, that is a
like
context.
one of the themes is, well, it might be easier to do that, you can just run OpenStack on top of Kubernetes.
Correct. Yeah.
And that requires some prep by OpenStack quite a bit. So then I'll be back to a topic of when you have a management framework, which OpenStack mostly is, there's the problem of managing the platform that that framework runs on. And that's different from running any other node in your network.
So this has been a dilemma. It's even a dilemma in the Kubernetes community. This is the underlay platform challenge, and there's a real desire for people to have the thing that is the platform run the platform. It's logical for developers because they understand the platform really well. Google's done some nice research and statements saying that there's a SRE, software readiness, where they actually identify a platform and below as a line and platform and above as a line. And so you're right, we still struggle with this. I feel like this is one of those, you sort of want to go to a 12-step program that says, first you have to admit you have a problem. Your problem is that you think that the underlay and the platform are the same thing. But yeah, it's an ongoing problem. I think that we need to, but disclaimer, I write underlay software, right, where we do metal and we do network topology stuff and physical stuff. And I'll tell you, because we use Kubernetes and containers and all that stuff, it's different. So, some of it's the same, but at the end of the day, you need the underlay to be solid, upgradable, transparent, all these things. And actually, this is a really good example, because my commentary about triple O, in some cases ironic, where they tried to make OpenStack install on metal. The benefit you get from OpenStack is you obfuscate all of this underlying complexity. Right? Kubernetes, same thing. You obfuscate networking. Awesome. Underlay, you obfuscate whether or not a service is running. You just give it to Kubernetes, it does it. Those exact things are what you need to know to run a platform. I care where things are running. I care that, so what I think we have to acknowledge, but it's hard to get people to do, is that the platform underlay pieces and the stuff you need to do a good job with that are different than the values of that platform itself. And so that's one of the reasons why I would say I would love to see OpenStack more Kubernetes friendly, but at the same time, there's stuff that it's going to be a long time before Kubernetes is ready to run your database in a stable, scalable way. That's just the reality of databases. It's not Kubernetes' fault. So, question?
I think you made quite a few very interesting remarks. I think it's quite insightful. I would like to make a comment. I think for the sake of OpenStack project, it would be a better idea to try to merge or combine with Kubernetes, whether it's underlay or overlay. Because if you look at the methods, probably people, not on the inside or outside methods, they will never think about combining with or merge with Kubernetes. Because these kind of OpenStack, of course, is very comprehensive and has quite a few years of history. So it has legacy, And there are so many developers surrounding. I think those cool features inside Kubernetes, it's not a rocket science to duplicate in OpenStack. That's not. By the way, what is the current status of the container project? Probably, archived by Chubak. Yeah. From at Rackspace,
I can't speak to the details. The challenge that you get with something like Magnum, I'll back up to the other question in a second, is, and a lot of OpenStack projects are like this, Designate's like this, Trove is like this. They're fundamentally running a application in a container. And so it's just setting up Kubernetes for you or Swarm for you. You can argue Trove, or like Amazon RDS, people actually want that, it's a valuable thing.
That's like a PaaS project, right? Platform as a service.
Well, but platform, but it's not exactly being platform as a service, it's really installing one of these container orchestration tools for you. All right, I would consider platform as a service another layer of abstraction on top of that. Something where you're taking code and automatically pulling the code down and running the code for you. Kubernetes is not Interplay Schaefer was tweeting in the background somewhere, so I can poke him. It's not platform as a service. That's one of his things.
Yeah, I agree with you.
Kubernetes is a sitting between infrastructure as a service and platform as a service. So you can say it's a containers as a service or something like that.
Yeah, I mean, the assets, I mean, that's, what Kubernetes is a container scheduler, and I think that's a reasonable thing. It's a multi-node container scheduler, and so you could call it containers as a service. I'm not sure what that really means from my perspective, because they would tell you that's too infrastructure-y in some ways for what they're trying to accomplish. Right, the thing that really helps explain Kubernetes is when you stop thinking of it in VM terms, like containers. It really is a service management. And what you're really doing is you're saying, I need to keep this service as API up. And I need to be able to scale it and migrate it and upgrade it and do all this stuff. It's really a service management infrastructure, and containers are the vehicle that you're using to distribute them. It's not, so calling it containers as a service puts you in this mindset of, I'm going to ship it a container, it's going to run a container for me. Kubernetes can do that, but it's really not the best way to use Kubernetes. Kubernetes is a service running service. As far as merging projects and stuff like that, I have some news for you.
It might end up with, I'm worrying about, but anyway, I'm outside. The end up with, the risk is end up with, it's going to be absorbed by Kubernetes.
So, I mean, I think OpenStack has, and I'm watching it in market, and it's got great adoption. It's actually being used productively by a lot of people, right? And I don't, this talk is not meant to detract from that. But in fact, it's clearly seeing market success. The thing that you would see though is that in the Kubernetes community, this might be a shock to people. They don't particularly see the OpenStack community as being productive the way they want it to be productive. And then OpenStack has some interesting biases towards Python projects where something like Mesos and Kubernetes and Docker and Rancher, our stuff, really predominantly in Go, right? So you get weird language variants that makes it hard to combine projects until communities decide that isn't the #1 priority of the value. So I don't expect to see these projects, sort of morph. I'd love to be proven wrong, maybe, but I don't see them subsuming each other at this point. And I think the market for container scheduling is way big enough that we're not going to see consolidation for a while. There's so much territory out there for these systems to go and pull down. I don't know how many of you remember the Chef Puppet Wars. Chef and Puppet spent a lot of time doing this instead of just going out and dealing with winning all the business they could win, helping each other. The container people, or the battles that you see with containers, are much more about pundits who want to see head-to-head competition, or Docker who fabricates. Maybe they don't fabricate it, but they're trying to grab market. Than it is. There's so much opportunity for people to move forward, and you do get somebody saying, should I use Mesos or Kubernetes? There's a balance there. Somebody asked me this. I'm preceding a question, but I'll actually let you ask your question. If you want to adopt containers, it really doesn't make that much difference whether you use Kubernetes or Mesos or Swarm or Compose or Rancher or any of the other 20 things out there, because you have so much architectural work to do to get into containers and use containers and make that work. My CTO was looking at, I was looking at, do you care? I was literally asking, do you care which container orchestration? He goes, no, at this point, we've migrated to containers from microservices, we use console to schedule things. It doesn't make a difference, really, to us. So it's not as big a deal as people think.
Because it looks like it's more about leapfrog. If you look at, if the new technology like a container, original VM, right? If OpenStack itself can deal with ironic, it's bare metal, and VM know pretty well. it can also deal with container like a Kubernetes, and you really don't need it.
So
That's called leapfrog. So if you look at, you mentioned the chef and cook. Now Docker is actually eating their lunch. Because with the Docker, theoretically you don't need a chef and cook anymore. Because they wanna grab the whole pie.
So there's something you're saying in there that I'm going to push back on. There's an architectural opinion about how software has been constructed, and you can't just leapfrog. You can't take OpenStack and the APIs for OpenStack, which are designed as infrastructure management APIs, and use them to leapfrog in Docker or Kubernetes, because the fundamental constructs of that API are wrong for the way people want to build applications using containers. They're not designed to run services, they're designed to run VMs and infrastructure. And OpenStack actually got a huge false start on that. Are you agreeing with that point? Or okay. OpenStack got a huge false start. This was at the Paris Summit where the whole Docker support thing just exploded because they were like, we're going to treat Docker like VMs. And Docker said, you can't. We use run files, our images are different. And they're like, no, we're going to do it anyway. And then there was a big fight, and then basically Docker became a pariah at OpenStack events. After Paris, there was like a year where Docker was a bad word at OpenStack summits. And there's just different constructs. And so that's where you really, they're different things, they should be different things. Don't count on OpenStack, Nova to do it. And I would tell you the same thing, don't count on OpenStack. I know there are people here who do it. I've talked to somebody from eBay, like, yeah, we use Ironic to provision Metal as VMs. Metal is a different beast than a VM. It has, you care about different stuff when you manage it, and containers are a very different beast. You can run containers like a VM, but the people who are really understanding 12-factor applications and immutable infrastructure and things like that, they don't think of containers like VMs at all.
Just one more thing. I totally agree, no one seriously gonna run a container on VM. But anyway, the thing is that if the whole architecture is truly immutable, then you can just like add a new microservice. You never touch the existing one.
Right, that's right. So the statement is that the architecture is immutable, you don't edit, you just replace.
Yeah.
And that's exactly why people do immutability, but to do that, you then have all these other architectural things that go around it, which is how you get upgrades, which is how you get HA, which is how the scheduling works. And one of the things that we believe in very strongly is that the world is hybrid, right? It's hard to make a database immutable. I'm sure there's somebody out there. I just saw a company called Snowflake that's doing some really cool stuff. It's hard to make a database with transactions immutable, and it's okay that it's not. It's hard to make a data lake in Hadoop in containers. There are people trying to do it, and they're using containers for packaging, and that's a big win, and they should definitely do it. But at the end of the day, it's okay that we have an underlay that has different operational constructs than our front-end frontier application. And in my opinion, the more we realize that we have round pegs, square pegs, and triangular pegs, and cope with it, the easier our operations teams are going to be about adopting stuff. The place where operations really gets frustrated is when they're square pegging that round hole. That takes a lot more effort for them than just running something. It's square, they deal with it.
And there's so much learning that still needs to happen here. We were at the Ops Summit, right? And as with the OpenStack New York, containers is still the conversation of the summer. And even OpenStack and Docker, what John from TTL Cinder, did his presentation was packed. And he was showing Cinder and Docker and but we got to
storage under,
and we got to the Ops Summit, and the first session, the whole morning really was on containers, and what we learned within in 5 minutes is that no one really knew what was, what they were talking about, and there was still a lot of learning that has to happen, and a lot of confusion, and lots of people thought, oh, containers are going to save the world. Oh, wait, it's not magic. And so once we pulled the wool away from the audience.
I mean, if it's worth anything, like the deployment I'm showing you, we don't containerize Kubernetes. We just run systemd with Go, or just Go. We just run systemd and Go. We're pretty happy with that. There's a lot of people who are containerizing Kubernetes to run Kubernetes. It's little turtles on turtles.
I feel like we've read that book before.
In some,
How well did it work for clouds, running clouds, and for, okay, one more question, and, wow, that was so
thank you for all staying so late.
Yeah, there was over 100 of you here, so this is clearly everybody's favorite topic still, so we will continue in future meetings with this. All right.
So Rob, great presentation, very much. Thank you. So I didn't catch the joke about the SSL certificate earlier. So how does it manage the SSL termination at the application level? How does container manage that?
How do the
Given that
containers manage
IPs keep
SSL
floating around?
certificates?
Yeah.
Oh God, you need to see the presentation. I did an hour presentation about PKI infrastructure. That is still a very active set of development. And actually Kubernetes, I love this about Kubernetes, requires you to have encrypted traffic between nodes. How many of you actually know how to build a PKI and roll certificates? How many of you have done it through your OpenStack services? Wow, all right, very awesome. Yay, thank you. Hey, two is a million, is an infinite percentage more than I expected to say yes, which is great. The reality is that we're having enough trouble building good PKI just for Kubernetes-based infrastructure, which is pretty simple. To do it for the applications, you still need to do it. People are using things like Let's Encrypt, and you can create a service that gets you a certificate and installs it. You throw in the load balancer, and now you've got the load balancer to the back end.
Right, but that's assuming.
I don't have time. If you go to my Twitter feed, I posted the presentation about exactly this topic. It's awesome. And your head will explode, which is, well, yours won't. Other people did. It was messy. It was really messy. They didn't like it, so nobody here. Listen, we have to keep the place clean. So,
Can you put that link in the Meetup?
I'm happy. I'm happy to do it. It was recorded. I don't think the recording's posted yet. The answer is it's still a field of very active pursuit. The simple answer is you put your certificate in your load balancer, and then load balancer takes your domain name, encrypt your traffic, and then it routes it in. But you still need to secure the traffic from the load balancer back, and which means you need a dynamic PKI. If you're interested in that, we're building that. Into key rotation and some really cool stuff that's hard to do. The platform I've shown you actually builds a PKI dynamically. We're really proud of it. So, yeah, that's awesome.
Yeah, so that's one problem. The other problem is like Keystone using for that token, for example, what we require encryption keys to be provisioned in the container, right? And I don't know how we manage those things.
So there's a secrets infrastructure in Kubernetes that injects secrets. So when a container comes up, you can inject secrets in it, sort of like a cloud init file. There's a similar concept in Kubernetes. But you have to make sure that that's secure, and you have to deal with it. A lot of people have been using a technology from HashiCorp called Vault. And Vault seems to help with this, but if you can open the vault if the way you open the vault with a token isn't secure, then you're not really you're artificial security with that stuff. So it's really tricky, and the big thing is that there's so much movement in these infrastructures, right? It's awesome. Yay! My containers are bouncing all over the place, keeping themselves healthy and alive, and everything's good. Oh my God, my containers are moving all over the place. I don't know where they are. I don't know what's going on. And so we're really trying to figure out how to do that, how to cope with an actual PKI when the IP address of my container is moving all over the place and my signed cert is no longer applies because my container moved. Those are real problems. They're not all solved.
Yeah, and also also, like, if I want a HA proxy for load balancing, right? I mean, how do I keep managing these IP changes? I mean, is that?
So that's a straightforward question. So so that I can give you a simple answer for. I love simple answers. Thank you for one. So the way Kubernetes works is traffic comes to the hosts, and then the hosts know where everything is, and they move traffic from any one of the hosts to the correct container. So that's the magic. So that's why I said if you only expose one host, it's going to send the traffic into your cluster correctly. So it doesn't matter where the container is, but you don't have HA, because now you've got that one point of conflict. So what you have to do is you have to load balance your traffic across the cluster in order for traffic to be distributed, and then the host will figure out where it needs to go and fix it behind the scenes by default using IP tables, but there's some other fancy tricks. The downside of that is that everything talks to everything.
Yeah, and tracing that call can be difficult. It's a little complicated.
It's depends on how much complexity you add into your environment. Yes, containerized infrastructure is trickier because the containers are very short-lived and they can bounce around everywhere. But logging constructs around containers are actually really, really good. And it's actually much easier to track traffic and activity and logging in these container infrastructures because of the logging generalizations that people have added on top. And so networking is networking is always hard. But logging and log aggregation in containerized workloads seems like it's really good. And people are pretty happy about that. And I like the stuff that we're doing. We spew all our logs to the console, to CONSOLE, to the console, and those can get then stuck into Logstash and then analyzed in Kibana, and wow, it's pretty cool. So plus and minus, get out of our log help.
All right, good stuff, thank you.
Thanks, Ron. And thank you for presenting at many of our OpenStack meetups as well. I love that the Keystone crew shows up, even when they're not speaking. And I think, can we take all the rest of the questions offline, or was there one more burning question? Were you pointing at someone specifically?
Nope.
Okay, didn't know if anyone was just dying to ask.
Sean's laughing at me.
Yeah, okay. So stay for the
Shane.
whole thing, Shane. Yes.
Sean's over there.
Yes,
And
Sean's
he's
back
not
with us.
laughing at me.
So I just want to thank everyone for coming. We're going to stick around because we need to move some furniture back. If you want to help, oh my gosh, you got a hug. Seriously. From you, take it
From either of us.
Either of us, absolutely. Thank you, Rob. Wow, thank you. Thank you, John, so much. Thank you, Ron. Thank you, Brittany. Thank you, everybody, for
Yes, this is
coming.
Still the top meetup. You guys are awesome.
Really appreciate it. Drive safely. Wow, I love the